All right. I think the most important thing with vectors is understanding the rotation. Rotations multiplied by r cis theta. Just that's probably the biggest thing. When you know that, the only other thing you really need to know, which is just a general rule that we have applied now, is vector of AB is vector of A naught plus vector of 0B or OB, whatever. That's it. Really, you're going to know that. If you do, these aren't too complicated. In the Argand diagram, OPQR is a rectangle. Fair enough. Where 2 times OR is equal to 3 times OP. You saw what I did. I would say that means vector OR, this one here, put an arrowhead, you know, vector OR is 1.5 times vector of OP. Let's rub out the top. Oops. We don't get ourselves confused. All right, so vector OR is 1.5 times vector OP. I could lock it, but whatever. And vector OP, if you're going to state that, draw your arrowhead as well. Don't just assume it. Draw your arrowhead so you can see where it's going. It says the vertex P corresponds to the complex number omega. It's important that you understand that means vector OP is omega. Do we understand that? Done. Okay, so let's just get something clear. This vector, because this is a big thing, this vector and this vector are the same. We agree with that? This vector, because it's the same as this vector, it can hold the same value, i.e. vector RQ is omega. It does not mean the complex number is the same. The complex number is not the same, obviously. So don't get into the words too much. Look at this complex number here. Look at that complex number there. It's a completely different complex number, right? That is like a positive and a positive, where that's a very large y value, whereas it's a negative x value. It's a completely different complex number. It can hold the same value, it's different complex numbers. It shouldn't impact you too much, that knowledge, but it's important that you understand that. So if I ever ask you to find Q, don't say, oh yeah, Q is omega. It's not like that. Why? Because Q starts, if I want to find the complex number Q, where does it need to start from? This is a very important thing you need to learn for all vectors. O must start from the origin. If you want to find the complex number Q, must start from O. We get that? Finito? Done. Delete. Back to where I was at. And delete. What complex number corresponds to the vertex R? So again, it needs to be, that means essentially I'm finding OR. So I now know I need to find OR, but I know OR is 1.5 times of OP, so therefore my answer is OR is 3/2 omega. Nah, that's not right, is it? Why? Because what have I missed? What does that mean when I'm saying it's 1.5 times omega? Come on, I really want you guys to understand it. If you said vector OR is 1.5 times omega, isn't this what you just found? Yeah, it's on the right direction. So what are you going to do? What was the rotation thing? R cis theta. We just did R. Where's my cis? Cis, what did you say? Pi on 2, 90 degrees. And what you want to remember is cis 90 degrees is always going to be I. So whenever you're rotating by 90 degrees, you can just multiply by I. If you're rotating the other way, clockwise, it's negative I. And then omega. So the answer that we're looking for is 3/2 Wi, or omega I. Got it? See how tempting it was to just go, oh yeah, vector OP is omega, so therefore 3/2 omega. No, careful. It's rotated. Do you get that logically?
I get that it's rotate.
Yes. Oh, because it's right angle. Look, what I want you to see, let's make it super simple.
Okay, yeah, I get it.
Are you sure?
Yeah.
Because
So
I don't want this to be like a whole, because to a lot of students that start this and don't get vectors, it's like, what is all this? It shouldn't feel like that. It should just be, look, you're here, you've got this size, whatever, think of that as 2 centimeters. You need to get it to like 4 centimeters. But it's not only just 4 centimeters, it's 4 centimeters rotated 90 degrees that way. Well, if I want to get it to 4 centimeters, I'll times it by 2. That makes sense. Then if I need to move it this way, we're saying you have to multiply it by cis of the angle. And that's it really. You can do that to anything, and then you can rotate any way you like. Good, if you say so. Double I. What complex number corresponds to the point of intersection S of the diagonals OQ and PR? And because it says complex number, again, that means you're finding what? Can someone tell me what I'm finding in terms of vectors? Has to start from the origin. So it has to be O. No, what am I finding? OS. I'm essentially finding OS. It's important that we write that as our first line. I'm going to find OS. Do we agree with that? Okay. There's a few ways. The best way to find OS, we said, because we said we know that diagonals in a rectangle, bisect, that means they cut in half. We said we're just going to find OQ and then half it. That's exactly what we're going to do. We're going to go a half, so vector OS is a half of vector OQ. So I always start with what I'm about to find. And I'm like, okay, I need to find, now I need to go vector OQ. What does vector OQ become? Arrowheads. Vector OQ becomes vector OP plus PQ. Let's see if it adds up to the addition rule that we know. Yep, P and P line up. Exactly what we want. What's vector OP? Omega. What's vector PQ? Well, vector PQ has holds the same value as OR. So really, PQ is right here. 3 on 2 omega I, and I think you guys get it, we're done. Vector OS is half of this. Half. Sounds good? Tell me. Yeah, tell me. OP plus PQ, yep. Come up, let's have a look at it.
Is that right angle true?
Say it again?
So just right angle true?
No. Right. No. 2 things I've done there. Got nothing to do with right angle trig. First thing I've done is just use my basic addition laws that I'm allowed to do with vectors. What do I mean by that? If I say vector AB, as long as the first one's A and the last one is B and these two are the same, that means these vectors will always add up. Always. So if I had said D and D, that's true. Is that okay?
Yeah.
So that's what I've actually done. I just chose P because I knew that was going to be the point between them. But the other thing that you need to know is all I'm doing, which is something you might understand, is I'm just adding head to tails. To get a resultant of OQ, I'm doing OP plus PQ to get to the resultant of OQ. You could have also said OQ is OR plus RQ. It's the same thing. That's all. So it's got nothing to do really with trig. It's not like that. Because it doesn't have to be right angle. It could have been non-right angle. It could be anything really. You're just adding vectors, right? Head to tail. That's how it works. That's it. In engineering, you don't do a resultant. I think you do equilibriums.
Yeah.
So that faces the other way around. That goes down. That's it. Okay. All good. Done. Let's try the next one. Let's try this. Don't overkill it. I used to overkill it. That's why I never learned it when I was at your age. I wasn't getting it. It wasn't taught like this to me. So I used to look at every question and think that every single question is different. I'm trying to make sure to tell you guys it's not different. see it the same way. Okay, let's read. The point A in the complex plane corresponds to the complex number Z. Stop. What's the first thing I write? No, vector. Vector. Don't say just A. OA. Please, it's got to start from the origin. It's got to have two things. There's no vector A's, by the way. It has to be two letters. So A, B, C, D, E, F, G, K, whatever.
Isn't it just a point of A?
No, but the point A starts from where? O, because for you to have a vector, it's got to start from O. For you to have a complex number, it's got to start from O anyways, doesn't it? Like you got to go 1, 2, 3, 4, 5, and then, so it's got to start from the origin. So it's always going to be O. Well, if it's a complex number, it's always going to be O. Does that make sense?
Yeah.
Which is like the topic. It's complex number. But when you do vector topic, just vectors like in 3 and 4, you're not really going to be doing any of this stuff anyway. You're doing different things. Vector. OA. You do a little bit of this, don't you? In 3 of vectors. Yeah, we did a little bit of just addition, subtraction and stuff. That's it. Vector OA. Any rotations? I don't think so. I don't think there's rotation because you can only rotate through cis. Anyways, OA equals Z. We're okay with that? Miss? 100%. The triangle OAP is a right-angled isosceles. Okay, fair enough. It's right-angled. It's right-angled. OA. Draw your arrow. Do not think you're going to get away without drawing an arrow. Draw your arrow. Right-angled. And your arrow is pointing towards A. Explain why. Never explain. That just means work it out. So find P, and hopefully it works out to be Z plus IZ. Okay. All right. So what do we know vector OP is? Vector OP is going to be vector. That's going to be part of our answer.
OP is OA plus AP.
Like that. That's what we want. So vector OP is vector OA plus vector AP. We already have OA. We don't have AP. That comes down back to what you were saying now. How do I find vector AP? Vector AP. AP is, by the way, this way. Yes. How do we find vector AP? OA rotated 90 degrees clockwise. So is it going to be a positive I or negative I? If it's clockwise, no, clockwise. Negative, right? Remember what we said, anti-clockwise is positive. Just what you've already done with Sokotoa and L Station Central, whatever, all that stuff. Anti-clockwise is positive. But will I find AP? Good job. That's it. So you're not going to be able to find AP yet. Ugh, let me lock it. Give me a second. Selection, lock, done. All right. So you're not going to be able to find AP. You'll find PA. PA. Why would you find vector PA? Because when you're going to rotate this, put your pens. That's what I used to do back at your age, right? I would put my pen, the pointer facing this way, then I would literally rotate it, and my pen point will be pointing that way. Can you see that happening? You guys can try it if you want on your papers or whatever. So you're actually going to be finding PA. So PA would be vector AP times negative I. Do we get that? Yes? No? Maybe? Why? Isn't it the same as me going times cis negative 90 degrees? Wait, do you get that one?
Yeah.
But then didn't I just say cis 90 is always going to be I? But then aren't you going clockwise? So then shouldn't it be negative I instead of positive I? Okay, fair enough. There it is. But then did we want PA? Well, what's this? What did I write AP for? Ugh. OA. OA. Did we want PA? No, we wanted AP. So what do I do with AP? If it's the other direction, what do you do? Not necessarily. It doesn't work like that. If you've got PA, the opposite direction. No. You just make it into an opposite direction. So OA was Z. So this was negative ZI. What's the opposite direction of negative ZI? Done. That's it. Simple. Don't overkill that. You're just changing direction. Instead of going -5, you're going +5. If you're going +5, you're going to go -5. That's all. You're just changing direction. And tell me.
Isn't timesing OA by I, wouldn't that just give you 8
Isn't timesing OA?
by I? Wouldn't that just give you 8? Because it's the same.
Yes. Yeah, that could have worked. So you would have rotated it 90 degrees this way.
No.
Yeah. If you had realized that. You only realized that because you got the answer at the end, maybe, but up to you. I'm going to say yes, you can. Is it intuitive? If you can see it, great. To me, it's not as intuitive. To me, it makes more sense to do that and then change the sign. Up to you. Okay, and then you're done. OA is Z plus IZ, finished. Exactly what you needed. Factorize your Z out, 1 plus I. That's what I mean, there's not really much I can teach you. It's more about you guys just doing it. There's going to be rotations, there's going to be adding of vectors. That's just how they work. All right, we'll do another one. Let M be the midpoint of OP. Let M be the midpoint of OP. I gotta get myself out of that one.
That's the last one.
Yeah, that's okay. Let M be the midpoint of OP. And look, are you still there? Or did I just disconnect that call as well?
No, I'm
You guys
not.
still on? Yeah. All right, double I. M is the midpoint of OP. So that means vector of what? O what? OM is equal to half vector. Oh, okay, we're getting it. And then OP is whatever you just found. So what complex number corresponds to M? It's literally half of Z 1 plus I. Yes. You sure? You sure? And Nook, you getting it?
I missed your explanation for double I.
No, there's no explanation, really. Vector OM is just half of the vector of OP.
Oh, yeah, and then you just sub in OP.
And you just sub in OP.
Oh, okay, yeah.
Yeah, no explanation there, really. That makes sense. Next one. Okay.
We try this one or?
True, beautiful. Why not? Question 14. Like I said, don't overkill it. Don't read into it too much. Don't think about, oh, how do I exactly show this? Like when you saw me, did I care about what he was saying to show? No, I just did what I know you've got to do. I'm like, okay, OP, let me just start with that. Let me add my vectors and so on. Attempt it the same way. Let's just see.
Why the two and the one like that? It doesn't make
The choose a square.
sense. The whole thing.
Z1 square.
Oh, okay.
Oh, no luck? Alright. Alright, well, we'll see. We'll see. Don't stress. It's good. It's good to actually try it for yourself because, again, it's different. It feels different. Let's see. The points. A and B in the complex plane correspond to the complex numbers Z1 and Z2 respectively. Right. So that means vector OA is obviously Z1. Vector OB is Z2. We got that? We wrote that. We wrote that. All right, fair enough. The triangle OAB is isosceles, which means this is equal to this, and right. Show this. Well, okay, the only thing I know is vector OB is also equal to, say that again? Yeah, which you would have done, but then you would have realized, yeah, wait. Then you realized, I don't know, what are you going to do with AB? Yeah? Then you're going to say, oh, AB is OA plus OB, whatever. It's just a mess. You're getting nowhere. You're going to go around in circles. You get what I'm saying with that? What's the only thing you actually know about OB?
OB equals IZ1.
Yeah, equals to OA times I, or what Anouk just said, IZ1. Isn't that the only thing you know? And then what does OA become? OA is Z1. So OB is Z2. And you're like, what? What the heck? How am I going to get squared? What are you going to do? What do you think I'm going to say? Do it. Do it. Squared. Both sides. Z2 squared equals I squared is negative Z1 squared. And then I think you guys can see it. You're done. Done. Just do it. Let's do another one. What do you reckon, Elliot? All right, let's try another one. Question 24 is good. I really think we should do 24. Because that probably eliminate a lot of the problems. Not an easy one, but I think it will eliminate a lot of the problems you might have. Again, have a read. Okay, what does it mean by, let's just get something clear. Now that you've read it, what does it mean that vertices P and Q correspond to the complex numbers Z1 and Z2? OP, yeah, that means OP, good. So we at least get that bit done. OP is Z1. And vector OQ is Z2. Now, what does it mean by they're parallel? Doesn't it also mean that vector PQ is the same as vector OV? You do get this. Good. Okay, well, we'll get to it as we need to. And then the question says, explain why the point V corresponds to this. Well, you can't. You can't do I. It's not meant to be done like that. It's meant to be done more through what I just said. You're going to actually find vector PQ. Vector PQ is vector P what? Plus vector what? Q. What does OQ equal to? What does PO become? Negative of Z1. So it's the opposite direction. Yeah, of course, right? Didn't we just say that before? You just swap them around. If you've got one, just other direction, just swap it. Negative Z1. Look, you're done. Didn't you just say vector PQ is the same as vector OV? Therefore, vector OV is equal to, because parallel.
This is only
Yeah, a parallel and equal to PQ and RS respectively. That means OW is parallel to PS. That's all. And look, it came up. What complex number corresponds to the point W? Now, poor students would have done, I don't know, trying to find PS. Maybe they'll try to use the same logic that you did in I. Wrong. How would you have done double I? OV, OW is equal to OV times just Cs 90 because it's a right angle. Cs pi on 2, which is I. OV, you're going anti-clockwise. No. OV, you're going this way. Anti-clockwise positive. That way. Left positive. So the answer is Z2I minus Z1I. And all good?
Yeah.
Has Queenie joined or not? No? Z2I minus Z1I. So it might look like, again, to you guys, at first glance, a little complicated. But once you break it down, it's okay. Triple I, last one. What complex number corresponds to the vertex S now? So now we want OS. Okay, so we're going to do it slowly. We know we're going to do OS. I think logically it would be OP plus. We all agree with that? Let's see. What's OP equal to? Right up here. Z1. What is PS equal to? Or isn't PS the same as OW? You're done. Come on. Can I make this topic any easier? I've done it really good. Over the years I've been able to teach this. I've been able to perfect this because this is really complicated to teach. But I think I think, you can give me feedback later, I think I teach it pretty good. I've made it as simple as it's going to be. That is as simple as it can be. Done? Done. Next one. One more. Tell me when you guys are ready. I guess let's try this weird one. Question 20. Maybe even that one. One more. Locus, locus, locus. No, that's it, just two left. Maybe I'll leave one for you guys. We'll leave this one for you guys. And we'll do this one together now. And if you guys think you can get it, then we can move on. Well, let's see. Another weird one. Let's see if we can answer this. The diagram shows points O, A, B, C, D. These points correspond to the complex numbers 0, alpha, beta, gamma, delta. Fair enough. The triangles OAB and OCD are equilateral. Let's okay, so let's make that into a theta. Just a bit easier to pronounce. There we go. Let theta equal to cis 60 degrees. Okay. Explain why delta is cis 60 of gamma. Obviously. We agree with that? Because part I. Vector OD is equal to cis pi on 3 vector OC. Vector OD is delta. Cis pi on 3 is theta. Vector OC is gamma. Done. That is your explanation. Double A.
And
okay?
for the explain questions, do we need to write something for them, or is working out?
No, not really. That is the explanation. Because what are you going to write? It's rotated? Fine, you can put that word in. But that's what cis pi on 3 is. UI extension 2. So you can't really fudge vector OD equals cis pi on 3 vector OC. You either know it or you don't. So, yeah, you don't need to explain that. Okay. Double I. Find the complex number alpha in terms of beta. Yes. But isn't OA also just like 60 degrees moved of OD? Touche. Right? Kind of thing? Yeah. Yeah, I can also write that. So why don't I just do that? Let me say vector OA is equal to, remember, keep your arrowheads if you have to so you don't mix up anything, but these are both going in the same direction, so they should be okay. We're going this way. Is that positive or negative? is actually negative because if this continues on a clock, that is clockwise. You can't do that. 50-50, don't go for the wrong 50. That's my whole thesis. Don't do that. Don't just pick a choice. Don't do that. Just take a step back. Anyways, OA is equal to negative, no, not negative I. Is negative 60 degrees. Is negative pi on 3 of vector OB. But we know cis negative pi on 3 becomes, just in case. Let me show you guys something. So cis pi on 3 becomes cos 60 half plus sine 60 root 3 over 2 I. This one, what should cis negative 60 become? Just by you guys seeing this and knowing by now cos and sines? Yeah, good. Why did you say that? Can you tell me what your thinking was?
Because I know if it's a negative side, it's just cos minus sine.
Yeah, good. So you memorize that. That's exactly what I was wanting to hear. Cos of a negative, we now should know that cos is always positive, because even. So that wouldn't change, and then it's just going to become minus sine. So half minus root 3 over 2. So find the complex number alpha in terms of beta. Alpha is equal to cis. You can't say that's negative theta, because it's not. Yeah, it's not. You can't say it's negative theta, so you just got to leave it as cis negative pi on 3 beta. Any questions?
You say theta with the polynomial?
Oh, fancy. Yeah, why not? I don't see what the problem with that is. Conjugate of theta, beta. Why not? He wants to be fancy. Let's give it to him. You don't have to. You and your math. Using complex numbers, obviously. But anyways, using complex numbers, show that the lengths of AC and BD are actually equal. Okay, interesting. So let's rub all this, wait. I'll make no mistake again. Let's rub all this out and see. Vector AC and vector BD. Okay, let me think for a second, because I'm in the same boat as you guys. All right, vector AC, what am I thinking? I'm thinking to do vector AC would be vector OC plus that, then that, then that. The math just works out. That's the truth. What I'm thinking is this. I'm thinking we just found a relationship between gamma and delta and a relationship between alpha and beta. So if I do a bit of math, hopefully the relationship works out. Let's see. So what I'm about to do, I don't think is anything, it's not going to come to us as a surprise to you guys. Ready? Vector AC. Vector AC is equal to vector AO plus vector OC. OC is equal to gamma minus alpha. Correct? Have I missed anything? I don't think so. You guys better be checking it. Vector BD. Vector BD we're going to say is vector BO plus OD. BO is negative beta. Yeah, I am missing it. Right here. I wrote alpha is theta conjugate beta. That doesn't matter. We'll get to that later. Yeah, tell me. Gamma, because gamma is OC. Alpha, because OA. OA is alpha, so AO would be negative alpha. Come on, change direction. It has to start from O. Yeah. You said that before as well. It's the second time. You can't say it third time. No more you gotta remember it. It starts from origin, so it has to be O, A, that's alpha or whatever. So OD in this case should be delta. No, I've forgotten how to run my deltas for some reason. No, delta minus beta. So far so good? Okay, now we go back up. What did we just prove? We proved alpha is literally cis negative 60 beta, and we proved delta is theta gamma. Okay, so maybe I'll just go down here for a second. Can someone say that again? I said alpha is, yep, thank you, cis negative pi on 3 beta, yep, and then what's the other one? Delta is theta gamma. So delta is cis pi on 3 gamma. All right, that means this guy became beta on 2 minus root 3 beta on 2i. True? This guy became gamma on 2 plus gamma root 3 on 2i. I'm going to sub in delta into here. So sub delta into here. That should become gamma on 2 why don't I like it? Gamma on 2 plus gamma root 3 onto I minus beta. Sub in alpha in here becomes gamma minus beta on 2 plus root 3 on 2 beta I. Okay, I've done something. Let me go back up. All right. Show that the lengths of AC and BD are equal. What does lengths mean? What's the word you've used a lot of in this topic for length? Modulus. So we're going to show that the modulus of this complex number is the same as the modulus of this. Ready? Modulus of AC equals squared. Let's write squared here. So I'm going to use the square root. Gamma minus beta on 2 squared plus root 3 on 2 beta squared, which becomes gamma squared minus 2 times alpha beta gamma, so that becomes just alpha beta plus beta squared on 4 plus 3 beta on 4 squared. That becomes gamma squared minus alpha beta. A quarter plus 3/4 is 1 whole. There we go. And then you got to square root it. Let's see if it's right. So what's the modulus of BD? And then again, I'm going to square it. Should be gamma on 2 minus beta squared plus gamma root 3 on 2 squared equals gamma squared on 4 minus alpha beta plus beta squared. I think we have just smashed it. Boom. A quarter plus 3/4 is 1 minus alpha beta plus beta squared. That was a serious question. That wasn't a messing around one, was it? 100%. I agree. I agree. I feel like there could be, but look, I didn't do it. So that just means my math took me here. Let's see the answers now. Which one? Which one? 3b squared, that one on 4. I'm just expanding, really. If root 3 gamma, this one, gamma on 2 minus beta, all squared plus underneath, gamma squared on 4 minus, oh, that should have been gamma, not alpha. Same. Even this one should have not been alpha, on the right, gamma. That should have been gamma, and then that should have been gamma. I don't know how I introduced alpha all of a sudden. I guess I'm used to, and then multiply just alpha beta. Anyways, gamma squared on 4 minus gamma beta, because the 2 cancels out, plus beta squared, plus gamma squared times 3 on 4. Let's see if there's an easier way. I believe there should be as well. So I'm not going to deny that, but I guess I couldn't do it. It's not what I would have naturally thought of. To me, that's what I would have done. Question 20. Done. All right, let's see. Vector AC, which is gamma minus alpha, double I, we'll talk about that in a second.
Please,
Yeah, we'll talk about that. We'll talk about it. Don't worry. AC, BD equals, well, if I knew this would have made life a little bit easier. But I didn't have on theta. I had a cis negative 60, so too bad on me. Let's get back. See, I didn't do it, so that's okay though. I still get 4 marks, just so you know. Let's see if this is true. 1 on z equals z conjugate. But it's not. Except in the case where z is equal to cis theta. 1 on cos theta plus I sine theta times cos theta minus I sine theta on cos theta minus I sine theta, that becomes, yeah, okay. They use this particular theory. See how we were talking about theory last week? And I'm like, oh, you're going to prove it usually. If you had known this particular theory, you could have used it. The fact that 1 on z is equal to a z conjugate. Only when z is equal to cis theta, not for x plus ry. That means your r is 1. Your modulus has to be 1. I don't memorize all this. You don't think of all the math I know. So maybe at your age, yes, you can do it. It's just I probably wouldn't have done it. I would have still done it, Stefan, like I said, the way I just learned it. Because I don't memorize that particular concept. But if you guys want to write it now, 1 on z actually is the same as z conjugate. Are you going to memorize it? I don't know.
So is that the conjugate of everything?
No, I just said only when its modulus is 1. So cis theta, with z is cis theta only. So this one gave us z is equal to cis 60. That's why instead of writing z conjugate, you could have written as 1 on theta. Fantastic. Would have made it a lot easier. But I wouldn't have known that. I haven't memorized that, let's say. I do know it, I haven't memorized it. If I had, that would have made it a bit quicker. Oh well. Doesn't matter. Not all is lost. At least you got to see a second way of doing it. You got to see a way that will never fail you, maybe doing it. And then I did the modulus. And easy. That's fine. It is what it is. Okay. Let's stop the recording there.